Having only a few days at our disposal, our small expedition team did not expect to make even a single discovery. But fate decided otherwise. Discoveries, or rather, things that contradicted the official point of view, started pouring in like a cornucopia, literally on the very first day. I reported on 2 such discoveries in the previous 2 films, respectively, but they didn't end there. Now I'll tell you about another mysterious find we made. And it's so sensational that I'm even afraid to draw any conclusions. But let me tell you everything in order. Let's try to figure it out now. So, you are on the channel Era of Distrust with Mikhail Khomikov. During our expedition, we discovered that the coal in the quarry is not distributed randomly. It is concentrated in specific layers, each of which is quite unique and has its own distinctive features. And this is true from the very bottom of the quarry. It's granite, meaning it's not just stone, but a solid, unified rock formation. And this fact doesn't quite fit with what we're told about the vegetation of the Carboniferous period. So it turns out that the trees, and it doesn't matter whether they were gigantic or not, grew directly on the rock, that is, with no soil layer at all. So right away, there's a tree or a fern, or maybe even some kind of grass. And in such quantities that, even after being compressed under pressure and turning into coal, they still formed a layer 10 meters thick. Yes, of course, vegetation can grow on rocks. Our Karelia, the surroundings of Murmansk, and the Kola Peninsula in general are examples of this. There are other examples as well, including in the south, in the Caucasus, where trees and vegetation in general can grow on sand or in rocks. The same goes for Vietnam and Angkor Wat, for example. Or you can recall Indian temples or Aztec temples overgrown with jungle. But there is one but. In any case, plants destroy the stone in which they grow. They cling to it, grow into the tiniest cracks, and then, as they expand, they split the monolith apart. But not in this case. Here the bottom is flat, granite, poured, like the concrete bottom of a pool. And right above it, without any transition, suddenly there is coal. The granite base of the quarry also once again casts doubt on the theory of hot gas paralysomethane coming out of the mantle. The granite cap simply doesn't let it out no matter how much it wants to. And if methane had enough power to break through solid granite, then why would it accumulate 20 meters below the surface under loose clay? In that case, the methane would simply burst to the surface like a geyser. On the other hand, the official version tells us that plants died off over the course of about 100 million years, give or take, and all this time they were accumulating in one place. And there were no bacteria that consumed cellulose all this time. But how is that possible? Where was evolution during all those 100 million years? Looking at how quickly the well-known virus mutates, producing new strains every 3 or 4 months, it's somehow hard to understand such indifference of bacteria to cellulose. Well, okay, let's assume that the virus mutations are just someone's clever manipulations for profit. But here's another example for you: plastic. It has existed for only 60 years, and it entered mass use just 30 years ago. And in these 30 years, we've managed to pollute half the planet with plastic. Burning plastic is prohibited because it is believed that dangerous dioxins are released into the atmosphere, which are supposedly harmful to the environment. The corruption of this point of view is a topic for a separate video. In the end, a single volcano emits more pollutants than all the burned plastic on the planet. But the fact that by getting rid of one type of pollution, we end up with another, even worse one, makes us think. And what about nature? How does it react to plastic? And in the meantime, nature's doing just fine. It's only been 50 years or even less, and the bacteria needed to digest plastic have already appeared. Of course, any knowledgeable scientist will say that these bacteria did not appear on their own. They were first developed by Japanese scientists, and then British scientists took over the baton. That is, they were specially synthesized. Honor and praise to our scientists. However, the devil, as usual, is in the details. Japanese scientists did not create this bacterium. Meet Adianella secensis. In March 2016, Japanese scientists in the city of Sakai, Japan, collected samples of soil, water, and silt from plastic recycling sites, including plastic bottles. And that's when this bacterium was discovered, which, with the help of a special enzyme, breaks down plastic. It is emphasized that the discovery was made by accident. Now, scientists are working only on modifying this enzyme. But in this case, what interests us is not that, but the fact that nature itself created an organism to counteract it. Moreover, pay attention to the time frames. Just 40 years ago, there wasn't much plastic waste, almost none at all. The peak started to rise about 30 years ago, in the early 90s. And just 26 years later, Japanese scientists discovered a bacterium that can break down plastic. If evolution exists, then here is its speed. 25 years and the bacterium is ready. In another 25 years, more complex organisms that consume plastic will appear. That's much faster than our laboratory work. Yes, what is a bacterium compared to that? Already, 2 species of waxworms have been observed to have retrained themselves to eat plastic. And now let's listen once again about how for 100 or more million years, there were no bacteria on Earth that could break down wood cellulose. Well, how about that, funny? It turns out that the fact of the presence of coal is not exactly inexplicable. No, there are explanations. Maybe not complete, and maybe not everything adds up. But in this direction, a plug has been put in place. Don't think about why. Well then, let's see what exactly we found. Yes. Here it is. This is wood, it's not even petrified. No, damn, you really need to pull yourself together. Here is coal. Here are 65 million years. How many is that, 65 million years? Oh no, Yura, that's 220 million years. Pure wood. Now that's a sensation, damn. Yes, friends, this is real wood. The most genuine, not petrified. The fibers are still relatively fresh, soft. We took several samples. Here they are now in front of you under the microscope at different magnifications. And again, according to geologists and paleontologists, this piece of wood is 200 to 300 million years old. But maybe there's no sensation at all. Let's ask the geologists on their official forum what they have to say about this. During another round of long arguments in the style of, "You're the fool, go study," this answer was given. Here's the thing. Before extraction, they conduct exploration by drilling. After the well is drilled, it is sealed so that during extraction, water does not rush into the mine through the well. Sealing is done in such a way that a pipe of suitable diameter is inserted into the wellhead and pressed down to a level below and then above the seam. Clay balls are thrown onto the pipe to create an insulating cover. It is also required to use a special spacer spring or one made from a piece of cable. But the drillers are often too lazy to do this. And if the supervisor doesn't keep an eye on them, they might do it without the spring. Because of this, sometimes the pipe sinks right into the formation, and then the miners have to pull it out. That's about it. I haven't seen any other explanations. Just like that very same plugging pipe that goes through the entire rock. But if we found something like this on the first try, has no one else ever found it or described it? Why? Supposedly, professional geologists turned the topic into a joke and in the end just tried to ridicule the question. But it's all very simple. Laughter is a defensive reaction of a person who doesn't have the information to maintain their authority from falling. Simply put, it's the fear of admitting one's own incompetence in something. It's obvious that there's no tampon pillar there. It's actually a tree, and its structure is soft, not at all like modern hard conifers, and yet it hasn't petrified. As for me, this is a real mystery that just doesn't fit with hundreds of millions of years underground. It doesn't even fit with a single million years. And there's also ash, clearly left from the burning of wood, practically in the same place, which leads to the conclusion that it was this tree that burned. But it didn't burn completely, apparently because all the oxygen had already been used up by that point. And under the burnt wood, there's charcoal. This involuntarily makes you recall the very process of artificial charcoal production. The wood is stacked in large pits, set on fire to achieve a high temperature, and then covered with a non-combustible material. Then, by carefully regulating the supply of oxygen so that there isn't enough for open burning, but just enough to maintain the temperature. I wonder where people could have observed such a technological process, knowing that our civilization is built on structures and methods borrowed from nature. I think that about 500 years ago, people could literally observe such remaining hearths with their own eyes and tried to model them on a safer and more controlled scale. However, we got a little sidetracked. The technical process of coal formation on the surface seems plausible, but it doesn't answer all the questions. And so, let's turn to history. Back in the first part of this series, I promised that I would return to Karl Friedrich Mohr and his work from the century before last. Let me remind you that most of the alternative theorists know him for his phrase about the periodic upheavals of the Earth, but official science is also well aware of him. First and foremost, he was a professional chemist. He is credited with inventing numerous chemical instruments such as Mohr's balance, Mohr's burette, and so on. They are still in use to this day. He is the author of methods for chemical analysis, particularly quantitative analysis, ways to detect poisons, and he developed the so-called Mohr's salt, which is used in medicine when a person has an iron deficiency in the body. He also introduced the very concept of a normal solution, so he can quite rightly be considered, at the very least, one of the founding fathers of modern chemistry. Therefore, I cannot distrust this scientist. And it was he who, in his work, Geology on New Foundations, using chemical analysis, completely destroyed the version of Sedgwick and Murchison about paleontological periods. Nevertheless, for some reason, official paleontology took the comparative method of dating epochs as its basis. From 2 British soldiers and a priest, they discarded the evidence of a professional chemist. So what did Karl Friedrich Mohr say about coal deposits? He said a lot of things. He tried with all his heart to figure out its origin. Well, for example, he was one of the first to point out the fact that in coal formations, you very often find almost whole tree trunks, both standing vertically and lying down. But they are found specifically inside coal-bearing formations, that is, right next to the deposit, actually within the coal itself. Almost never. For example, he writes about this on page 109, third paragraph from the top. That is, in other words, the fact that whole tree trunks are found in coal-bearing rock does occur. It has been known for more than 150 years, and only pseudo-geologists on the Paleontological Forum believe that this doesn't happen. You say there's no conspiracy. Well, Mohr didn't think so. He conducted a lot of research trying to study the process of coalification and how tree trunks ended up standing upright inside coal-bearing rocks. He studied the speed and intensity of wood decay and concluded that such a position is explained by water. Yes, tree trunks float on the surface of the water, but only because there is air inside the wood. As soon as the air completely or partially leaves the tree trunk, it begins to sink. And since the tree's roots are heavier than its main trunk, they often sink vertically with the roots downward. As a result, you get trees that seem to be standing on bare granite. However, further reasoning leads to two conclusions. First, the trees did not end up in the coal-containing layer on their own. They were clearly brought here by some kind of flow. Secondly, they were brought and surrounded by water. And thirdly, the coal mass itself was formed not from the trees, but from something plant-based that was present in huge quantities inside the flow that brought the trees. On one of the pages, Friedrich Moore mentions an entire forest of petrified trees between Suez and Cairo in Africa. According to him, for 16 miles in every direction, there are petrified tree trunks whose petrification occurred right on the spot and apparently quite quickly. Experiments conducted by him with various types of wood show that under normal conditions, no coal can be obtained from wood. It simply rots, turning into dust. To obtain coal, high temperature and the absence of oxygen are required. Also, MOR completely rejects the theory that coal originates from peat, since peat prefers stagnant swamp water, while trees prefer dry soil. Growing in different places, they cannot mix with each other in any way. Peat can only accumulate where it grows, while trees never form deposits in place, as forests all over the planet prove. It turns out to be some kind of mystery, but Karl Moore found a way out of it. Yes, indeed, nowadays trees rot away, leaving behind nothing but dust, which then serves as a nutrient medium for other plants and organisms. From this, paleobotanists concluded that since the trees became petrified, it means there were no bacteria. But it turns out things are actually not quite like that. There are plants that leave behind coal specifically, and they still do to this day. But more on that later. Karl Moore carried out a series of logical calculations, which he then verified with fairly simple experiments, on the study of the ratio of carbon dioxide, nitrogen, and oxygen in sea and river water, as well as in lake waters and basins with clean water. As a result, he discovered a clear discrepancy in the ratio of gases. The prevailing official theory at that time and now about the saturation of water with carbon dioxide and oxygen from the surrounding air suffered a crushing failure. It turned out that there was an order of magnitude more carbon dioxide in seawater than there should have been according to the official version. And this confirmed Moore's hypothesis that coal seams were formed not from trees, but from carbon-containing marine algae like Fucus giganteus. I won't quote him in full. It's quite a massive work of more than 500 pages. Anyone who's interested can read it. But most importantly, it contains answers to many questions. For example, the nature of coal deposits. In many cases, they form as large lenses, that is, as if in the place of bodies of water with a significant accumulation of algae. In our case, it looks more like huge deposits of biomass as a result of some global catastrophe. This theory also answers the question about the presence of tree trunks in coal, including those standing vertically. They were simply preserved in the viscous mass. Among the algae, this also explains the absence of animal remains in coal. Moore simulated the process of algal coalification on the sea floor and discovered the release of large amounts of carbon dioxide and other acids, which, when unable to escape to the surface, simply dissolve all the organic matter. From bones to soft tissues, acid after all. It also becomes clear why there is a large amount of methane and ammonia in coal deposits. Sklerov believed that it seeps up from the Earth's mantle. While in the very initial composition, There was a huge amount of water, which through chemical interaction produced methane and other hydrocarbons. Moreover, during monitoring and further compression, coal loses the last remnants of hydrogen and oxygen, forming hard coal, anthracite. Methane, on the other hand, escapes to the surface, meaning there is no pyrolysis involved. There, Karl says reproachfully, page 132. The remnants of terrestrial plants found in coal in a highly destroyed state and reconstructed only by the imagination of botanists can belong only to those that grow in unchanged conditions and are subject to the destructive force of rivers. And he concludes with the words of Geyer. Some kind of endless sadness is spread across the images of the coal era. There are no flowering plants, no higher animals. Not a single bird flutters among the branches. Not a single beast brings the forest thicket to life. At the same time, the air is stifling, filled with vapors. The ground is hot and smoldering. There is a deep silence, undisturbed by the sounds of living creatures and broken only by the noise of rain and the howling of the wind among the tops of the dark, hard-leaved trees. One can only marvel at the strangeness of such conclusions. Since there are no animals in the coal, it follows that they did not live in that era. But can a horse or a goat now end up in the Sargasso Sea or in the sea near the Falkland Islands? Can a camel be found in the coral reefs of the Mediterranean Sea or a cow in the oyster beds of the English coast? By what process would a magnolia or tulip petal carried into the sea be preserved? Postscript. The discovery of an entire piece of wood, not petrified, tells us that the catastrophic process that formed the coal deposits happened quite recently, certainly not millions of years ago. Coalification does not indicate that there were no bacteria during the Carboniferous period, but rather that coalification occurred underwater, in conditions of preservation and further oxidation. Chemical processes and an aggressive acidic environment left bacteria with no chance of survival. The trees covering the coal layer above accumulated in one place where the flow hit the granite walls. At that moment, it was very hot. It was so hot that the trees on the surface burned, as indicated by the wood ash found on top. However, they were not able to burn completely as they were covered by layers of volcanic ash and then clay. So what kind of apocalypse was happening on Earth at that time? Well, or at least in the Rostov region. We will return to Karl more than once. And now the story continues. The story continues.